So in a previous video, we talked to you about relations and functions, and we defined a function as a set of ordered pairs in which for each value of x, you only have one value of y. And one of the things that we did was that we looked at sets of ordered pairs, and we would know that if our x coordinate was repeated in more than one point, then that was not a function, right? That relation. An example being here, example number 2, where you have this ordered pair -2, -7, and this ordered pair -2, 9, and we have repeated x's there, so that one x value of -2 is resulting in two different y values, the -7 and the 9, so that would not be a function. So now we're going to take that idea and apply it to graphs of relations to see which graphs represent functions and which do not. And the good thing is that we're going to have a test that we can use to show quickly which graph represents a function. So let's talk about that. So when we look at graphs, we want to be able to tell if the graph represents a function, and we've got what's called a vertical line test. And what that says is that if you can draw a vertical line that intersects the graph in more than one point, then the graph does not represent a function. And I'm going to show you with the first example why that works. Okay, so the first example here you can see is a circle. And with our circle, can we pick out 2 points that have the same coordinate x but different y values? And yes, here's one, and here's another one, for example. This point right here on the circle has coordinates 2, 2. And then this point down here has coordinates 2, -2. So there are 2 points that have repeated x values with different y values. But the other thing I want to show you is that I can draw a vertical line through those 2 points, and that's why this is called the vertical line test. So because we can draw that vertical line that joins those 2 points, we call this the vertical line test, and it tells us that this circle is not a function. Again, because those two ordered pairs have repeated x values, right? They have the same x values but different y values. And we could have drawn that vertical line anywhere. We could have come over here on this other side and drawn a vertical line. If you can draw one vertical line through your graph that joins two ordered pairs on the graph, then you do not have a function. So this is not a function. So let's use the vertical line test now on our next problem. It's a graph of a parabola. And is there a way for us to draw a vertical line that's going to join two ordered pairs here? Not really, huh? Anywhere we draw a vertical line, we will only cross the graph in one ordered pair. And you know these go forever, but they are going at an angle. So yeah, this is a function. This parabola is a function. So yes, a function. What about drawing a vertical line that cuts through 2 points, that intersects two ordered pairs? And we can't, can we? Now, this little area right here, let me zoom in a little bit. That little area near the origin almost looks like it's vertical, but it really isn't a vertical. It's more of a elongated S shape, so there's a bit of a tilt there. So this is a function. Yes, this is a function. Okay, let's do a couple more. Okay, this is another parabola, but this parabola opens to the side. Do you see that? And can we draw vertical lines joining 2 points? I bet you said yes. Here's one. This would join this point and that point right there. Here's another one that would cross through two ordered pairs with the same x value and different outputs. So this is not a function. So the sideways parabola, not a function. Okay. And then what about number 5 here right next to it? This is called a hyperbola. So this was a parabola, but sideways, right? And this is called a hyperbola. Do you think it's a function, the hyperbola? No, not a function, right? Because here's one vertical line where we would be joining these 2 points, same x values. We could draw another one here, right? So the hyperbola is not a function. You'll be doing more work with hyperbolas also in your college algebra course.